Hello everybody. Alright, we're going to talk about horizontal asymptotes in this video. We're still dealing with rational functions. And we've already covered vertical asymptotes, and now we're going to look at the horizontal portion. And the main question is, when is there a horizontal asymptote? We have three scenarios. 1, 2, and 3. And even though there's a lot of writing here, there's not much to it. So the very first one I want to look at is when the numerator and the denominator are the same degree, meaning they have the same power in that leading term. Okay. Then the horizontal asymptote is simply y equals a over b, where a is the leading coefficient in the numerator and b is the leading coefficient in the denominator. And let's look at example a over here. Given the function g of x, if I look at the leading terms in the numerator here and in the denominator here, I see that both are to the same degree. Therefore, the leading terms are the same degree. I will use y equals a over b, where a is the leading coefficient in the numerator and b is the leading coefficient in the denominator. My horizontal asymptote is simply y equals 3/4, a horizontal line. Let's look at that in Desmos real quick. This is, in the blue, is the graph of my rational function. You see three different sections here. This is my horizontal asymptote, the dotted line, and it goes through 3/4. That's the value of 1 right there where my pointer is. Okay, so right there is about 3/4. There's 1/2. So this is my horizontal asymptote. What I would also like to point out to you, though, is that within your rational functions you can have horizontal asymptotes and vertical asymptotes. If I were to take my denominator, which is, and we set it equal to 0, and solve and find my vertical asymptotes, I end up with the value of x equals plus or minus the square root of 3 divided by 2. So again, we'll go back to Desmos and we're going to pull that up, and I'm going to show you that you can have all of those on there. And if you look, these are like boundaries or guidelines for where your graph will go and what it'll get close to. Again, with my vertical, it will never touch a negative square root of 3 divided by 2, and it will never touch the square root of 3 divided by 2. But for my horizontal asymptote, y equals 3/4, your graph can touch and go across the horizontal asymptotes. It may do that. It doesn't always, but it may do that. So here is a rational function illustrating the horizontal and the vertical asymptotes. I can only have one horizontal asymptote in my graph, but I can have multiple vertical asymptotes. Let's look at the next one for horizontal. When the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the x-axis, or y equals 0. And that is illustrated in example B in the function h of x. This is the example to where the degree of the numerator is less than the degree of the denominator. Therefore, my x-axis, or y equals 0, will be my horizontal asymptote. Let's look at Desmos for this. And for this one, we're just going to look at the horizontal. Okay, so the degree up here is 1 and the degree here is 3. So the numerator is less than the denominator, the degrees. So my horizontal asymptote is the x-axis, or y equals 0, and that is illustrated by the red dotted line that goes through there. You can look at this though and say, okay, I know I'm going to have some vertical asymptotes in here. Okay, for this, it's just a matter of looking at the degrees. If the degree of the numerator is less than the degree of the denominator, then we'll have a horizontal asymptote of y equals 0. And then our last one is actually very simple. There is no horizontal asymptote if the degree of the numerator is greater than the degree of the denominator. For instance, in example C with the function f of x. There is no horizontal asymptote for x squared minus 4 over x. And I went ahead and wrote in the 1 for the powers. That's an understood 1 that's there, but just to help to illustrate it. And again, let's pull up Desmos and look at the graph of the function. All right, and as you can see from the graph, we cannot have a horizontal line. It's going to intersect all of these. All of these are two sections of a rational function. So no horizontal asymptotes whenever the degree of the polynomial in the numerator is greater than the degree of the polynomial in the denominator. So as you notice with those different types of examples that we looked at, the three different ones for horizontal asymptotes, you can see that they can have vertical asymptotes along with having horizontal asymptotes. Something else to point out, or two other things to point out, there can only be one horizontal asymptote, and the graph may cross a horizontal asymptote. It may. And what this is leading to is, at least the last example, and I'll pull Desmos back up, is leading to oblique asymptotes. And that's where this will come into play for this one, an oblique asymptote. Okay guys, so that was horizontal asymptotes. Quick review of it. When the numerator and the denominator are the same degree, then I say y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. When the degree of the numerator is less than the degree of the denominator, my horizontal asymptote is simply my x-axis. And finally, when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, please watch the publisher's videos. Please structure and critically think about your work. And good luck on the rest of your homework.